Hi, this is Don, and I want to run through very quickly a problem that a lot of people are stumbling on, and it has to do with a paired samples t-test. You can do this very quickly if you've got an Excel spreadsheet set up. I don't have one handy, so I'm going to do it using StatCrunch. The first thing we have to do with every hypothesis test is identify the null and the alternative and decide which one is the claim. In this case, reading through this, we're talking about consumer ratings for last year and this year. The company wants to know, can you conclude the ratings have changed? If they've changed, that means the difference is not equal to 0. If we have an inequality in the mathematical expression of the hypothesis, that has to be the alternative, and that means the claim has to be the alternative. The product ratings have changed, and our setup there is mu d equal to 0 for the null, mu d not equal to 0 for the alternative. That's important because you have to know whether you have a one-tail or two-tail test. Always, if you have a inequality in the alternative, that is a two-tailed test, and you will have two critical values. Now I'm going to go ahead and copy this data into StatCrunch. Let that load. Okay, we have our data. The first thing I want to do, though, is to get my critical values. And we go to Stat, Calculators, T-Test, and we know that the distribution curve is symmetrical, so all we have to do is solve for one value and then put a plus or minus as appropriate on that. We need the degrees of freedom. In this case, we have 8 items, so our degrees of freedom would be 8 minus 1 or 7. Our alpha is equal to 0.05, and this is important because we've got a two-tail. We need to put half of that, 0.025, and we get a value in the left side of minus 2.365, and of course by symmetry we know that on the other side of a two-tail we have a positive 2.365. Okay, now I want to actually run the hypothesis test. We go to Stat, T-Stats, because paired samples are always a t-test, and we open up the paired t dialog box. Our first column is the rating last year. Our second column, our sample, is rating this year. It's important when you're doing these tests in MyStatLab that you save the differences, because you'll need that to find the S sub d bar that we'll need for the answers. Then we've got to make sure we've set up the hypothesis test. The mean difference is equal to 0, and the alternative not equal to 0. It default to not equal, but make sure it is set that way. And then we just click compute, and we get our basic answer. We get our mean difference, which is minus 1.375, and let's go over here, scroll down to the next 3 answers there. Whoops. And that matches. Our mean difference, d bar, is minus 1.375. We need our S sub d, which is the standard deviation of the differences, and that's the reason we saved those differences a minute ago. But let's go ahead and look. We've got our t statistic over here, minus 2.896, and if you remember, our critical value right there, I've got it, is minus 2.365, so our t statistic is over here somewhere, which means it's in the rejection region, and we reject the null. We also know that because the p-value, 0.02, is less than the alpha of, I'm pretty sure that was 0.05. So yes, that tells us again that we need to reject the null. Okay, let's get the last piece. You scroll back over here, and when I checked, if you remember, you go back here to edit, I checked save differences, and so now we've got our differences saved, and we need the standard deviation of those differences, and we can get that again through stat, summary stats, column. I'm going to pick the difference column. We need the standard deviation. I click compute, and we get a standard deviation of 1.302, which matches. And really, that's how fast you can run through this. Hope this helps.